Good morning, Mananda. Myself, Sreevani, working as an assistant professor in the Department of Electronics and Communication Engineering in Institute of Aeronautical Engineering, Dundigal, Hyderabad. So, in the today's lecture, we are going to solve some of the problems based upon electric flux density and energy density in electrostatic fields. The topics involved in electromagnetic waves and transmission lines. So before going to solve the problems are based upon this electric flux density and energy density, we need to know the relation between electric flux density D and the relation of energy density in electrostatic fields. So the first one. So electric flux density generally is represented with the D bar and it is given by the relation with the electric field intensity as D bar equal to epsilon into E bar. For a free space medium, it is represented with epsilon naught and D bar equal to epsilon naught into E bar is the vector. And generally it is measured in coulomb per meter square. Electric flux per unit area. And electric flux is given by electric charge and it is measured in coulombs and it occupying some area, so that area to be measured in meter square. Hence, electric flux density D can be measured in coulomb per meter square. And the relation between this flux density and energy density in electrostatic fields, that is WE, stands for energy density in electrostatic fields, is given by 1 by 2 integral V d dot E dV, where D is the electric flux density and E be the electric field intensity. Or if you want to express D by epsilon into E, then it will be given by here WE equal to 1 by 2 integral V, then epsilon naught into E square dV. Right? Either of the formulas we can use to solve the problems based upon this energy density in electrostatic fields. Right? So here electric flux density D bar is given by epsilon naught into E bar, and the energy density in electrostatic fields is to be derived as the equation is given by WE equal to half into integral V d dot E dV, or 1 by 2 integral V epsilon naught E square dV. So where integral V stands for here for volume integrals, means it is an example for three-dimensional one. Then the first problem is given on electric flux density is determine D. D is the notation for electric flux density at 4, 0, 3 if there is a point charge, that is charge is given as a point charge is to be considered with the notation as Q, and it is given by minus 5 millicoulombs at 4, 0, 0, and the line charge, that is 3 continuous charge distributions in the electrostatic fields as rho L, rho S and rho V. Rho L is the line charge density, rho S be the surface charge density and rho V be the volume charge density. So 3 continuous charge distributions. Along with this 3, we have here the line charge is given and it is to be measured in terms of coulomb per meter, in where its value is given as 3 millicoulomb per meter. Hence 3 L, rho L is equal to 3 into 10 power minus 3 coulomb per meter is given along the y-axis. So suppose if you are assuming, see here, if you consider an axis as a three-dimensional view is representing x, y, z. If you are assuming if the point charge is located on x, means the q is to be at minus 5 millicoulombs, and along the y-axis we'll have line charge located, that is rho L is equal to 3 millicoulomb per meter. Now we want to evaluate electric flux density D due to the point charge as well as the line charge, right? So it is to be given by here electric flux density D, that is D equal to total electric flux density D due to a point charge is given by dq plus due to the line charge is given as dl, right? So now the formula for this dq is means in general the electric field intensity E due to point charge is given by E equal to q by 4 pi epsilon naught r square into AR. And if you substitute in place of E by in the flux density equation, that is epsilon naught into E, there is the general formula, then epsilon naught into q by 4 pi epsilon naught r square into AR. If you write, then this epsilon naught gets cancelled. Q by 4 pi r square into AR is the formula for the electric flux density. Now, by comparing this electric field intensity with electric flux density, where electric field intensity is dependent on the medium, whereas electric flux density D is independent of the medium. So, consider this is the one of the formula to find dq. dq is equal to q by 4 pi r square into AR. Right? And we know that the unit vector formula AR is given by R by its magnitude. Then from this, dq can be considered q by 4 pi modulus of R whole cube into the vector form as R bar. To find this vector R, see, determine D at this particular means 4, 0, 3. If there is a point charge, means Q value is given as minus 5 millicoulombs at 4, 0, 0. So, distance we need to find the between the field point is given as 4, 0, 3 and the source point is between 4, 0, 0. Then, now to find, see here, Q value is given, that is minus 5 millicoulombs and 4 pi. Then R value is to be evaluated between 4 to 4, 0, 3 to 4, 0, 0. And to find the flux density due to the line charge, the formula is given by. So electric flux density, electric field intensity E due to line charge is given by rho L by 2 pi epsilon naught rho into A rho. Now, if you consider for D, it is rho L by 2 pi rho into A rho. So, along the line means the source point is at 4, 0, 0 means the rho is to be considered at this particular point. Hence, DL need to be written as rho L by 2 pi rho into A rho. Okay. So, this is the way we can find if we substitute rho L value by here 3 millicoulombs and 2 pi rho in place of rho, the distance is given by means A rho. This can be written as A rho by rho can be written as rho by modulus of rho whole square. And the distance between these two means 4 square plus 3 square. If you find like that, then rho can be written as root over 4 square plus 3 square, which is equal to 5. 4 square is 16 and 3 square is 9. Then 16 plus 9 becomes 25. Root 25 can be written as 5 square root. Square root gets cancelled. Rho value is to be obtained as 5. Right? So now this 5 value is to be substituted over here and A rho. Then we will be getting the value of DL. Then after getting this DQ, by adding these two, then we'll be get the value as D equal to DQ plus DL need to be obtained. And generally it is to be measured in terms of coulomb per meter square. Right? So this is the way. If the flux densities of, now to find the electric flux density due to a point charge or the line charge, or whether the surface charge and volume charges are also given case. If it is surface charge, then ds can be written as rho s by 2 into an. Then this is the case, surface charge density is supposed to consider. And if you want to consider for the volume charge, then it will be q by 4 pi epsilon naught r square into AR. Means no need to consider epsilon naught. Why? Because this is given for the means as we know that electric field intensity due to the volume charge, that is q by 4 pi epsilon naught r square into AR. Then if you consider the formula for the D is given by epsilon naught into E, and this epsilon naught here in the denominator epsilon naught gets cancelled, then dV for the volume charge electric flux density. Then if in the formula itself, if the volume charge is present case, we used to consider the flux density due to volume charge application. Okay. So now to find the total flux density due to point charge as well as the line charge, we need to add the two. Next, the 2 point charges minus 4 microcoulombs and 5 microcoulombs are located at 2, minus 1, 3 and 0, 4, minus 2 respectively. 2 point charges are given as Q1 equal to minus 4 microcoulombs and Q2 equal to 5 microcoulombs are located at R1 2, minus 1, 3 and 0, 4, minus 2 respectively. If the points are given, we need to write the vector form. How we will write means, along with the components, we have to express the unit vectors also. Then R1 can be written as 2ax minus ay plus 3az. Similarly, R2 is given as R2 equal to 0, x component as 0, y component is 4ay minus 2az is given. If the 2 point charges are given, and along with the 2 position vectors R1 and R2 are also given. Now find the potential at 1, 0, 1. So the V is supposed to find at a particular distance as R, assuming 0 potential at infinity. So one reference node is given as 1, 0, 1, and another will be is located at infinite region. This is the case. The electric potential is to be evaluated. V is equal to, generally, the formula is given by work done per unit charge as one of the formula. Potential is equal to work done per unit charge, or work done is equal to the potential is to be multiplied with the charges. Or electric potential V in terms of E is given by V equal to integral L E dot dl is the one of the formula. Or for the point form case, we can consider it as minus del V equal to E bar. Gradient of a negative rate of or decrease of the gradient of the electric potential yields us electric field intensity, and the relation between electric field intensity and the electric potential is given by E equal to minus del V, or integral form means V is equal to minus integral L E dot dl. So to find here the electric potential, in order to find, the formula is Q by 4 pi epsilon naught into R minus R1 into R minus R1 plus Q, let it be Q1, here it will be the Q2 into R minus R2 by 4 pi epsilon naught into R minus R2. This is the, if you have n number of point charges case, that n value is to be given as 1 and 2. Hence, Q1 into R minus R1 by 4 pi epsilon naught into modulus of R minus R1 plus Q2 into R minus R2 by 4 pi epsilon naught into R minus R2. As we know that R value is given as 1, 0, 1, R1 as 2 minus 1, 3, and R2 be the 0, 4, minus 2. So first find R minus R1. So R value is 1, 0, 1 minus 2, minus 1, 3, which is given as 1 minus 2 means minus AX, 0 minus of 1 plus AY, then 1 minus 3 becomes minus 2 AZ. Then modulus of R minus R1 becomes root over, see, 1 plus 1, 2, then 2 plus 2 is 4. Sorry, 2 square becomes 4, then it will be given by here 1 plus 4, which is equal to root 6 is the magnitude of this R minus R1. Similarly, next one is R minus R2 we are supposed to consider. Then R value is 1, 0, 1 minus R2 is 0, 4, minus 2, which is equal to AX, then minus 4AY, then plus 3AZ. See, 1 minus 0 is 1 AX, 0 minus 4 becomes minus 4AY, 1 minus of minus 2 becomes plus 1 plus 2 as 3AZ, right? So R minus R2 equal to this one. Then modulus of R minus R2 equal to root over, see, 1 plus 4 square as 16 plus 3 square as 9, then it becomes root 26. Okay. Now substitute this R1, R2 and the magnitudes of both will be in this equation. Then V equal to. So what is the value of given is given minus 4 micro. Means we need to write it as minus 4 into 10 power minus 6 into R minus R1. Means minus AX plus AY minus 2AZ by then 4 pi epsilon naught. Means instead of considering here 4 pi epsilon naught, its value 1 by 4 pi epsilon naught. As we know that 1 by 4 pi epsilon naught value to be is 9 into 10 power 9 meters per farad, and that value need to be substituted over here into 9 into 10 power 9 by, in the magnitude case, as root 6. Okay. Then plus Then Q2 value to be 5 micro into 10 power minus 6, and 1 by 4 pi epsilon naught value directly I am consider it as 9 into 10 power 9 into R minus R2, means AX minus 4AY plus 3AZ, then by, and root 26 can be considered. So which is equal to, see here 10 power minus 6, and it will be multiplied with 10 power 9, then it becomes 10 power 3. Then this minus 4 is multiplied with here, means 4AX, then minus 4AY plus 8AZ by root 6, then, and is to be multiplied, means 9 into 10 cube is the common for between these two factors, and plus 5 means 5AX minus 20AY, then plus 15AZ by root 26 is to be considered over here. So upon simplifying, means AX coefficient is multiplied over here and here by adding with root 6 and root 26. Upon simplifying, we will be getting the value to be electric potential is to be obtained as, and generally it is to be measured in terms of volts. Okay, so this is the way we can find the electric potential if the 2 point charges Q1 and Q2 along with the 2 position vectors are given case. Okay, so then next, a cylindrical capacitor has a radius as A equal to 1 centimeter and B equal to 2.5 centimeter. Generally, the capacitor is having two conductors, nothing but two plates, as a inner plate is having the radius as 1 centimeter and the outer plate is having the radius as 2.5 centimeters. If the space between the plates is filled with an inhomogeneous dielectric with epsilon r equal to 10 plus rho by rho, where rho is in centimeters, then find the capacitance for the capacitor. So a cylindrical capacitor is given, then we need to find the capacitance value of a cylindrical capacitor as 2 pi epsilon by ln of B by A. ln of B by A. So which is equal to 2 pi epsilon, means epsilon value is to be considered as epsilon naught into epsilon r by ln of B by A, means which is equal to 2 pi epsilon naught, means its value to be 10 power minus 9 by 36 pi, as we know that epsilon naught value equal to 8.854 into 10 power minus 12, or sometimes we used to consider in the problems case 10 power minus 9 by 36 pi. Okay, so now substitute in place of epsilon naught by 10 power minus 9 by 36 pi into, and epsilon r as 10 plus rho by rho into ln of B by A. Okay, so now if you simplify this equation as then here pi gets cancelled, this gets cancelled, then it will be given by here C is equal to 10 power minus 9 by 18 into 10 plus rho by rho into ln of B by A. ln of B value is to be denominator, ln of B by A. B value is to be 2.5 centimeter 10 power minus 2 by A value is to be 1 centimeter. Okay, so upon simplifying the entire equation, and where rho value to be in terms of centimeters is given, now finally the value is to be obtained and it should be measured in terms of farads. Capacitance is generally measured in farads, right? So cylindrical capacitor value is given with the internal radius and the outer circle radius as 1 centimeter and 2.5 centimeters. If the space between that will be given as epsilon r, that is 10 plus rho by rho, then where rho is in centimeters, then find the capacitance for the capacitor. And the cylindrical capacitor means we used to consider the formula as C equal to 2 pi epsilon by ln of B by A, where V be the outer conductor radius, and A be the inner conductor radius. Okay. So in the problems case, we used to consider epsilon value as in different cases. We used to consider the epsilon value as 8.854 into 10 power minus 12 in sometimes, and in some other cases 10 power minus 9 by 36 pi also. Next, 3-point charges 2 microcoulomb, 4 microcoulomb and 8 microcoulombs are located at 0, 0, 0 and 0, 0, 1 and 1, 0, 0 respectively. Then find the energy in the system. So as we know that electric potential V is equal to work done per unit charge, and we are supposed to consider here work done is equal to this electric potential is to be multiplied with the charges. Okay, so here V1, let it be Q1 V1 plus Q2 V2 plus Q3 V3. Why? Because three charges are given. Q1 value is to be 2 microcoulombs and Q2 to be 4 microcoulombs and Q3 to be 8 microcoulombs. As we know that micro representation as 10 power minus 6. And these three are respectively positioned at R1, R2, R3, means 0, 0, 0 as the R1 and 0, 0, 1 as R2 and 1, 0, 0 as the R3. Okay, then energy we need to find. So energy is equal to, we have to find over here as Q1 into V1 plus Q2 into V2 plus Q3 into V3. So Q1 into V1 can be written as Q1, V1 can be written as here. And in the energy density formulas case, that can be written as W1 is equal to 0 case and means total work done. In order to find the total work done in the electrostatic fields, the formula becomes W1 plus W2 plus W3. So initially, if you are assuming the energy is to be the work done in order to place the first charge Q1 from infinity region to the point P1 and from point P2 and from the point P3. So from initial it is to be a free space region, means the charge which is to be assembled, this infinity region to point P1 will be equal to 0, then W1 is equal to 0. To write the formula for this W2, we just consider here the charge which is associated with this W2 is Q2 due to the potential from 1 to 2. So that can be considered as here V12 and related to the 3 also V13. Plus similarly, if you want to find this one, then the charge is associated with is here Q3 and it can be written as V21 plus V23. Okay, so this is the way if you consider, then the formula becomes here V1, V2, V3 are given by here. For the first case, Q1 means the charge which is associated with this is Q2 into Q2 by 4 pi epsilon naught into R minus Q2, V12 means R1 minus R2 first case and minus plus Q3 by 4 pi epsilon naught into R1 minus R3 as the first case plus Q2 into V2 no. So the charge which is associated with is here Q3 V21. So first charge is Q1 by 4 pi epsilon naught into R1 minus R2 and plus charge is which is associated with is here Q3 by 4 pi epsilon naught into R2 minus R3. So like this, if you write the formula for this, then substitute in place of Q1, Q2, Q3 and here also Q2, Q1, Q3 by Q1 value as 2 microcoulombs, Q2 as 4 microcoulombs and Q3 as the 8 microcoulombs, along with the three position vectors as R1, R2, R3s 0, 0, 0, 0, 0, 1 and 1, 0, 0 as respectively R1, R2, R3. Then total energy which is present in the system by adding 3 will be W1 plus W2 plus W3 by simplifying total equation. Thus, finally, the work done or the energy which is assembled in that particular system is to be measured in terms of joules. Okay. So, firstly, to write the formula for this, we are assuming initially it will be in the charge-free region, and we want to locate that charge-free region to the charges respectively Q1, Q2, Q3s are to be placed in the respective positions as P1, P2, P3. So, in order to assemble these charges at the particular positions, we need to consider some, along with the charges, potentials need to be assembled. So, those potentials are given by here with the W1 as 0, and for the W2 as like this, and for the W3 as like this. If the charges were positioned in the reverse order case, we just add here instead of considering P3 first and next as P2 and next one as P1. So by adding those two, then finally we will be getting the work energy which is present in that particular will be adding in the normal order, and in the reverse order case, then we will be getting the formula as W equal to W1 plus W2 plus W3. By adding these three, the energy which is to be present in the system due to the three charges are to be obtained, and that can be measured in terms of joules. Next, given that D as Z cos square AZ coulomb per meter square, cos square phi Az coulomb per meter square, and calculate the charge density at 1 comma pi by 4 comma 3. Then the total charge enclosed by the cylinder of radius 1 meter with Z value is ranging -2 to +2 is given. So with the help of first given electric flux density, due to that we will find first charge density. The charge density and the relation between charge density and the electric flux density D is given by rho V equal to del dot D bar. As we know that vector D bar can be written as dx ax, or here rho phi z are the components are given, hence we will write it as d rho a rho plus rho d phi a phi plus dz az is the general vector form. Now d rho, d phi and dz components are to be considered from the given vector as d. Here z direction component only is there, hence we need to consider z component only, and rest of the two becomes zeros. Now substitute here formula dou dz by dou z is the formula. So which is equal to dou by dou z of dz means z cos square phi is the value for the z component. So z direction component only is there, hence we will consider it as dz. So in place of dz, if you substitute z cos square phi, now we are differentiating this one with respect to z, means cos square phi is a constant, then dou z by dou z value is 1, hence rho v can be obtained as cos square phi. Okay, so rho v means volume charge density at particular point, means rho is given as 1 and phi value is to be 5 by 4 and z is to be given as 3. Now instead of in place of rho phi z here, if you consider 1 pi by 4 and 3 in the respective equation, which is equal to cos square phi values here pi by 4. So cos 45 as 1 by root 2, then cos square 1 by root 2 means its value becomes 1 by 2. And this rho v can be given as 0.5, 1 by 2 as 0.5, and generally it is to be measured in terms of coulomb per meter cube. Right? So rho v equal to 0.5 coulomb per meter cube is to be obtained. Then after this, total charge enclosed by the cylinder of the radius width, means the charge which is involved in the cylinder of radius with a rho value as 1 meter is given. We need to find charge. Then Q is equal to, the formula is integral S rho S, rho V dV is the formula, right? So which is equal to integral V, triple integral, rho is equal to 0 to 1 meter is given, then phi is equal to 0 to pi by 4 is given, and z is equal to the value -2 to 2 is to be given. See, the total charge enclosed by the cylinder of radius means rho is ranging from 0 to 1 and phi is equal to 0 to pi by 4 and z is ranging from, or now to find the volume charge density, rho value is to be given as pi by 4. By default, it is ranging from 0 to 2 pi. And z is equal to minus 2 to 2 is given. Then rho v is to be substituted over here, cos square phi. Before substituting the values of 1, pi by 4, 3, whatever the equation which is to be obtained, that value to be considered over here. Into dv means rho, d rho, d phi, dz is the formula for the cylindrical coordinate system differential value. Then which is equal to. Now rho is there. If you integrate that one, rho square by 2, limits are 0 to 1 meter. Then cos square phi. So that can be written as 1 plus cos 2 phi by 2. Then if you consider integration for this, phi minus phi plus sine 2 phi. And if you take 1 by 2 as out of that, then if you substitute 0 to 2 pi limits, then 2 pi 1 by 2 into 2 pi plus sine 4 pi, and if you substitute over here 0, then tau becomes zeros, right? So sine 4 pi, and it will be, now to substitute over here, this will be the negative term. Now 1 by 2 into 2 pi minus sine 4 pi, it will be sine n pi values are to be zeros, hence 2 pi means 2 gets cancelled. Then after the integration of this thing, then pi is to be obtained for the phi component. And dz means z is to be written. And why? Because there is no z component, then integration of a constant becomes that respective variable. Then z is to be given. Then minus 2 to plus 2 are the limits which are equal to. Now substitute rho square by 1 and 0 means if you consider 1 and pi into z value is to be 2 minus of minus 2 means plus 2, then it will be 4 by 2 into pi is to be obtained. Then 2 gets cancelled, 2 pi. So as we know that pi value, that is 3.14, 6.28 coulombs are to be obtained. Right? This is the way. If the electric flux density is given, then from that how to find the charge which is exist in that particular, this is the way we can measure. Right? And electric charge can be measured in terms of coulombs. Next is if D equal to, vector D is given as dx and this is dy and this is dz. Right? Dz value is here x. And generally this D can be measured in terms of coulomb per meter square. Then find the volume charge density at minus 1, 0, 3 and B flux through the cube defined by this ranges are given as 0 to 1, 0 to 1, 0 to 1 as x, y, z. And the total charge enclosed by that cube also we have to find. So first to find out the volume charge density. So to find the volume charge density, rho v equal to del dot t bar is the formula. So that is dou dx means dou dx by dou x plus dou dy by dou y plus dou dz by dou z. Now dx value is to be 2y square plus z, dy is 4xy, dz is x. So dou by dou x of dx is 2y square plus z plus dou by dou y of 4xy plus dou by dou z of dz means x, which is equal to. So dou by dou x of this thing means there is no x component, hence it is 0, plus dou by dou y of 4x plus z component, hence it will be equal to 4x. Now substitute in order to find volume charge density. Here is minus 1, 0, 3. Means x value is minus 1, y value is 0 and z is to be given as 3. Now substitute in place of x, y, z by those 3. Hence rho v equal to minus 4 coulomb per meter cube is to be obtained. Okay. So then the flux through the cube defined by means flux we can find psi is equal to integral s d dot ds. Right? So ds can be written as, so integral s d dot ds, and we know that the flux through the cube defined by means the formula is given by psi is equal to closed integral s d dot ds. So this is the way if you expand this equation, the formula becomes, for the first case, if you consider xy, x is 0 to 1, y is also 0 to 1. D means the formula for this is ds can be written as dx dy into az. Means we have to consider only x component over here. X az into, okay, then plus integral y z, y equal to 0 to 1, z equal to 0 to 1, and x az means the formula for ds is here dy dz into ax. Ax component is what? 2y square plus z into ax. Then plus double integral z is equal to 0 to 1, then x is equal to 0 to 1. Zx component means the formula is dx dz into ay. Then dx dz into ay means this can be written as here y component as 4xy into ay. Right? So as we know that dot product representation of same unit vectors result as 1, then az dot az as 1, ax dot ax as 1, and ay dot ay is 1. Now by simplifying this equation, x means x square by 2, limits are 0 to 1, y limits are 0 to 1, plus. And here if you integrate this one, 2y cube by 3, limits are 0 to 1, into z limits are 0 to 1, plus z square by 2 limits are 0 to 1, and y limits are 0 to 1. Then plus here 4xy means 4x square by 2 limits are 0 to 1, and y is to be a constant, and z is there, then for z it is 0 to 1. And by default we know that y variable is to be given as 0 according to the this one, or if you consider the limits, y value is to be 0 to 1. So upon simplifying all this, we will be getting this one. Flux can be some finite amount, and it will be equal to, see, 1 by 2 here first, 1 by 2, then plus here 2 by 3, then plus here 1 by 2, then plus 4 by 2 into y as 1. Then by simplifying this thing, 1 by 2, 2 gets cancelled, then 1 by 2 plus 2 by 3 plus 1 by 2 plus 2. So if you take LCM as here 6, and if you simplify that thing, then 3 plus 2 3 is 6 means 3 plus 3 2 is 6, 2 2 is 4 plus 3 plus 6 2 is 12. So 12 plus 3 15, 15 plus 4 19, 19 plus 3 22, 22 by 6 is to be obtained, and generally it is to be measured in terms of coulombs. Okay. Then the total charge enclosed by the coulomb cube means that can be given by here q is equal to integral v rho v dv. And formula for dv is given by, in terms of Cartesian coordinate system, variables are given x, y, z. Then formula for dv is given as dx, dy, dz. Okay. And in place of rho v, if we consider the value as 4x, right? So q can be written as triple integral 0 to 1, 0 to 1, 0 to 1. Why? Because x, y, z are ranging from 0 to 1 itself. Then 0 to 1, 0 to 1, 0 to 1, 4x, dx, dy, dz. Okay. Upon simplifying this thing, then this q and this psi must be equal. Why? Because according to the Gauss law, that charge enclosed by that surface and the total flux which is passing through that any closed surface must be same. Right? This is the way. If the electric flux density is given, now how we want to find the volume charge density? Based upon that, how to verify Gauss law, we have solved based upon this given. Okay. So if the electric flux density is given, then some charges are given. How we will find the electric potential and energy present in that particular system, and the relation between electric flux density and volume charge density. Depending upon that, we have solved some of the problems based upon energy present in the systems, and along with that, We have solved some of the problems based upon electric potential. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.